So we were talking last day about displacement and first of all, we started out talking about vectors and scalars. Zach, we said vectors have magnitude only. A good example of scalars have magnitude only. A good example of a scalar would be mass. That has a mass of 12 kilograms. It makes no sense to say it has a mass of 12 kilograms north. And it doesn't even make sense to say that has a mass of negative 12 kilograms to so backwards. None of that makes sense. Vectors have magnitude and direction. We said there's speed and velocity. Speed is a scalar, velocity is a vector. Although we're going to be kind of sloppy a little bit this year, we're really going to focus much more on vectors in Physics 12. You'll learn vector mathematics. But for now, our typical response will be if we notice things are moving in two directions, we'll let one direction be positive and the other direction be, and we'll just keep it that way. Okay? We talked about distance versus displacement. Distance was how far you walked. Displacement was your change in position. We talked about velocity and speed. And we said that average velocity was displacement over time. Average speed was distance over the time. The two equations looked really, really similar, except this is scalar, scalar. This is vector, vector. Okay. If average velocity is displacement over time, what would be an equation for displacement and for time? What I'm going to be introducing you to this unit is what I call formula manipulation. And what I mean by that, Cal, it's the ability to rewrite an equation in your head without actually having to write anything down. And I'm really going to challenge all of you to reach that stage, to get good at that stage. So let me give you an example. This says, what would be an equation for displacement? The equation I gave you, you can write this down, is V equals D over T. I'm going to ignore the vector symbols. I'll bring them in at the end, and I'm going to ignore the I'll bring them in at the end. I just want to work with this. I want to turn that into D equals. What side of the equation is the D on? What that means is the left side is just going to drop down like a domino. And there's the equal sign. What else is on the same side as the D? A T. What's the T doing to the D? Adding, subtracting, multiplying, or dividing? So dividing by T on the right is the same as doing what on the left? Multiplying. This is really your equation solving rules that you learn in math, but we're doing it algebraically, and we're going to take it to a pretty much higher level. So I would argue that sticking a T right there, that's a new equation. VT, you could write TV, but if I write TV, you'll all get distracted because it's television, so VT equals D. Although typically we put the thing by itself on the left, so instead of writing VT equals D, we would write D equals VT. And now I can say, I guess displacement equals average velocity times time. That's a new equation. Did I give you that one on the front of your green sheet? I might not have, because I know I'm pretty sure I gave you this one, did I not? And I would argue if I've given you that one, I've given you this one in disguise. In fact, how many variables are there in this equation? You know how many equations it contains? 3. Not a coincidence. So here's an equation for finding distance or displacement. Distance would be speed times time. Displacement would be velocity times time. How would I get the T by itself? Well, I could start with this equation, but where is the T right now? On the bleh. I would start with this equation. I would say to myself, I know that D equals VT. I would write that down. Eventually, you'll be doing a lot of this in your head. I want to get the T by itself. What side of the equation is the T on? Left side's going to drop down like a domino. I almost always do that first because it gives me kind of a frame of reference. I imagine the equal sign right there. Can you just imagine the equal sign there, but don't write just imagine it there. Use your Sesame Street imagination. I have V, oops, I erased the D. I have VT. I want to get the T by itself. What else is next to the T? What's the V doing to the T? Adding, subtracting, multiplying, or dividing? So how would I move it over? Except, look up. Instead of writing D over V equals T, do you mind? I'm going to put the T equals on this side because that's where we're used to seeing the thing by itself from our math days. If you want to find time, you can find time if you know the distance and the speed, or you can find time if you know the displacement and the velocity. They both work. Is that a hand up?
Yeah.
Yeah.
You did have the D.
Did I? Yeah, I might take it off next year. Physics 12, I give you less and less, because in Physics 12, you'll have mastered this an awful lot. So we kind of now have 3 equations to play with. Often what I will do, now physics, I gotta be honest, it's word problems, but it's not the stupid word problems you get in math. The ones in math are dumb. First of all, they're very contrived. Often they're like, I would never do it that way. But one of the big challenges in math is you're always trying to figure out what the heck are they asking me to find. In physics, it's much, much, much easier. So read along with me. It says this, example 7, a motorist travels 350 kilometers during a 6-hour period. What's this question asking me to find? What was his? Doesn't say, well, read carefully, please. What was his average speed? Okay. Who remembers what letter did we use for speed? What was our abbrev? It was a lowercase v without the vector symbol. So if you haven't figured it out already, Ashley, I'm big on writing something down before I even really jump in. For unit conversion, write down what they gave you, right? I really like that philosophy. So typically what I do is as soon as I figure out what they're asking me to find, first of all, I notice there's a part A, so I'll write part A. And I write this down, V equals question mark. That's my way of saying, look, I know what they're asking me to find. Also, by the end of the year, when you've learned a lot more physics, that will dramatically help you narrow down where on the green sheet you're looking, or what area we're looking in. Then I go back and I look for numbers and physics words. I scan the question for numbers and physics words, and I haven't taught you any physics words yet. We'll get there. But for now, what's the first number you see? 350. What are the units right next to that 350? Is that time? What is that a measure of? I write that down. I see a 6. See it? What are the units next to that 6? Is that velocity? What must hours be a measure of? This is why I said to you yesterday, it's really worth memorizing what units go with what concepts. And because I hate memorizing stuff, if I tell you something is worth memorizing, that means it's really worth memorizing. Right? You're awake now. T equals 6 hours. Read, what does this want me to find? I'm looking for an equation that has a V, a D, and a T in it. Preferably it has the V by itself. There is one. Which one? What's D? 350. What's T? 6. By the way, what does A want the units to be in? Will this give us kilometers per hour? What units are on the top here, Zach? Invisible, but I didn't. And what units are on the bottom? That'll work. Okay. We are going to have to pay attention to units, though. If this time had been in seconds, I would have to do a conversion. For now, 350 divided by 6, you get 58.3. Oh, what did we decide yesterday? Aside from on your test tomorrow, how many sig figs are we going to go to in our final answer? 2 or 3. So I'm going to go 58.3. Why would I take off a half mark here? Verizon, right? Units? Okay. B. You'll notice often I'll draw a box around my final answer. That's sort of like when a football player spikes the football after a touchdown. That's just my way of, that's the answer, ta-da. You don't have to. It's just something I have a habit of doing. B. Raj, what's B want me to find? Average speed. Didn't we just find average speed? What's the difference between B and A? What does part B want me to find it in? Miles per second? M is miles? Think I'm American? No. What's M? We're proud Canadians, my friend. Yeah? Meters per second. And this is our preferred unit of speed in physics. I will usually give you a speed in meters per second, except cars. And I want to try and do applications that are interesting to you. So I will often give you a speed in kilometers per hour. And we'll need to do a conversion, unless the question wants us to leave it in kilometers per hour like part A. So here's what we're going to do. We're going to get clever. We're going to do the conversion together as a group once. We're going to add the conversion trick to our green sheet at the bottom of the front page. So don't write this next bit down, but look up. We're going to convert from kilometers per hour to meters per second. What was the number that they gave me? Was it 58.3 repeating? Yes? Don't write this down, just watch. I want to end up in meters per second. So I guess I need to get rid of kilometers, change it to meters, and I need to get rid of hours, change it to seconds. Yes? Okay, let's get rid of kilometers. On the bottom, yes. Hey, this is a good review for the test tomorrow. On the bottom, what's going to go on the top? Meters, and what else? The what? Yeah, which is what? Okay, 10 to the third. Good. And then, I guess to get rid of hours, it's going to go on the top here, because it's on the bottom. Anybody remember how many seconds there were in an hour? So here's what I notice. You multiply by 1,000 and you divide by 3,600. You know what? This is what we're going to write on our green sheet. At the bottom of your green sheet, write a little kilometers per hour, leave a space, write a little meters per second, draw an arrow, an archy arrow going from kilometers per hour to meters per second. And then on that arrow, you can write divide by 3.6, because I think that's what timesing by 1,000 and dividing by 3,600 is the same as. This is one of the few times we'll write down a shortcut, because we're going to use this so often. If you want to go from kilometers per hour to meters per second, you divide by 3.6. Oh, and by the way, if you want to go from meters per second to kilometers per hour, you don't divide by 3.6. Can you guess? You times by 3.6. Is that enough for you to figure out from the diagram what I'm getting at? You could write a big paragraph, Marcus, but hopefully you've noticed I tend to abbreviate. I want to write lots of information with as little writing as possible. So to go from kilometers per hour to meters per second, divide by 3.6. To go from meters per second to kilometers per hour, times by 3.6. Some kids end up memorizing that one because they get sick of looking it up, and you can, but it's on your green sheet now, on the front page. That's what I've said several, but okay, or on the back page, but since we're going to be on the front page for most of this unit, it would have been smarter to put, but whatever. So I guess B, I'm going to take 58.3 and divide by what? But I'm not going to take 58.3. I noticed on my calculator that I have this sitting as my answer still, so I'm actually going to use my answer button. Why not be a little more accurate? So if you use 58.3, go ahead, but I'm going to go answer button divided by 3.6. Why not? And if I do that, I'll get 16.2 meters per second. 58.3 kilometers per hour, that's roughly road speed. It's either 50 kilometers per hour or 60 kilometers per hour. So just to give you kind of a context, right around 16 or 15 meters per second, that's car speed on suburb roads, but not on highways or freeways. Turn the page, or next page over. I like example 8, I like example 8, I like example 8. Example 8 is a nice question. Why would I say that? Did you hear me say that? You just notice when a teacher tends to emphasize certain things? Good, 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 good. The speed of sound is 330 meters per second. Sheldon is shouting at the base of a steep mountain. By the way, the speed of sound varies. It depends on altitude, it depends on temperature, it depends on humidity. So it can be anywhere between 330 to 350. Oh, it depends on the substance you're going through. Speed of sound through water is different. Speed of sound through metal is different. But the speed of sound through air, it's actually 343 meters per second, but I use 330. Sheldon is shouting at the base of a steep mountain. If the mountain is 420 meters away, how long will it take before Sheldon hears an echo? I don't know if you've ever been in a situation where there's a really good echo, but that's some really cool physics going on there. What's this question asking me to find? Time? How long is a tricky one? Because if I say to you, how long was the movie? That's time, 2 hours. If I say to you, how long is a football field? Nobody says 3 hours. They understand it's talking about a distance. So yeah, you'll have to kind of figure it out from the context, but I agree with you. Okay, now I'm looking for physics numbers. What's that 330? I don't think that 330 is meters. I think it's meters per second. So what's that 330? As a physics concept. Is it time? It's speed. It's speed. V equals 330. What's that 420? Is it time? What are the units after it? Meters, so that's gotta be a distance. Looking for an equation that has a T, a V, a D in it. There is one. Which one? T equals V over D or D over V? I gotta scroll back. D over V. Distance divided by speed. So it's going to be 420 divided by 330. What do you get? What do you get? I get 420 divided by 330. I get 1.27 repeating. So I'll go 1.27. Why is that wrong? It is wrong, and there's a candy if you can tell me why it must be wrong. Yeah? No, even if I put seconds there, it's still wrong. Why? Is this? Wrong. For an echo. If the mountain is 420 meters away, I won't hear it in 1.27 seconds. Why? Yeah? What? Candy for you. Loud and proud. What? Echoes work by going there and back. So what's the real distance? Not 420. You could either go 840, or I can take my time answer and do what with it? So I'm going to go times 2, and if you want to, you can make a little note there and back. So we can't just plug and chug numbers mindlessly. We always have to think, does this answer fit the real life situation? Nice. Usually it takes longer and I have to give more hints before somebody spots that. Or if you don't want to write there and back, you could draw a little diagram or something, right? Be organized but lazy. I get 2.5. Is that 4 going to stay a 4 or become a 5? Oh, by the way, I used my answer button. I did not go 1.27 times 2. Why would I do that when I have it sitting on my calculator and can just use my answer button? So I went answer button times 2. When I do that, I get 2.55, not 2.54. And by the way, if you're ever at a good echo, if you time how long it takes for the echo after you speak before you hear it, divide the time by 2, you can actually figure out the distance by using this equation, D equals V times T. Figure out how far away the cliff is that you're echoing off of, which is kind of nerdily cool. Example 9. Jeremy is driving at 18 meters per second. If he drives for 2.5 hours, how far will he travel in kilometers, in meters? Okay. I'll write down A. What's this question asking me to find? Yeah, this is what, do you see what I said? Physics word problems nicer than math ones because you can figure out what they're asking you to find pretty easy. It's how or find the. Okay, so I'm going to go mark as D equals question mark. What's that 18? What are the units next to that 18? Meters per second, so what must that make it? It's a speed. What's that 2.5? Why is this question yucky compared to the other ones? Yeah, Marcus. My units don't match. I can't just go, don't write this down. I can't just go, oh, D equals VT. It's going to be 18 times 2.5. Most common mistake, kids don't pay attention to the units. They just kind of start plugging and chugging. So the first thing you want to check if your answer doesn't match my answer key, check your units. What do we want part A to be in? What does it say it wants my answer to be in? So I think I'm going to change this one to kilometers per hour, and that's hours. That should give me an answer in kilometers. I could change this one to seconds, get an answer in meters, and then change that to kilometers, but I'm lazy. So I'm going to say underneath the V equals 18, I'm going to say V equals meters per second to kilometers per hour. It's something to do with the 3.6. Is it times? I'm going to go 18 times 3.6, and I get 64.8 kilometers per hour. Looking for an equation that's got a D, a V, and a T in it. There is one. I think D equals VT. Yes? What I'm going to use for V, 64.8. What am I going to use for T? By the way, look up, don't write this down, but just look up. Notice if I put the units in, can you see that hours cancels that? And I end up with kilometers, so the units do work. I tend not to put units into my calculation because I find it really clutters things up, but you can if you want to. What is 64.8 times 2.5? How far will we drive? 162? Units? Got to be kilometers. 162 kilometers. What does B want me to do? Convert the kilometers to... Can everybody do that in their head? What? It's because you're getting your licenses soon. It's probably worth you just learning that there are 1,000 meters in every kilometer. So 2 kilometers is 2,000 meters, 5 kilometers is 5,000 meters, 100 kilometers is 100,000 meters, 162,000. Okay, so meters. So this is kind of the starting point of kinematics, but there's a bit of a problem right now. The reason I'm often saying average velocity or average speed, right now we can't accelerate because we don't know how mathematically. I can't let you step on the gas or step on the brakes. We're going at a constant speed, constant velocity. We'll bring acceleration in a few days, and then stuff gets much more interesting because then we can speed up and slow down and free fall and all that. But first, a little thought puzzle. Example 10 says this. An object can have a positive distance while having a displacement equaling 0. True or false? We're going to vote. How high you hold your hand up is how sure you are of the answer. I'm positive. I'm pretty sure. I'm only voting because Mr. Duke, put your hand down, will make fun of me if I don't vote. And Mr. Duke will make fun of you if you don't vote. Is that a question or read or a vote? Okay, so here's the question again. True or false? An object can have a positive distance while having a displacement equaling 0. Who says, Mr. Duick, that's totally true, absolutely true? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Who says, Duick, you're cuckoo for Cocoa Puffs? It's false. It's totally false. Okay. Me? Yeah. Nope. Wasn't there. I am the judge, so I don't vote. Convince me. So you can either attack someone else's answer as I know that's wrong, or defend your answer as here's why it's right. Convince me. Read. Actually, let's go Ange.
If I were to walk from my house to my house and then back from my house to here, I would still have to say 10 meters, but I would end up in the same place.
Although I would say I don't think you live 10 meters from here.
Well,
but
no, but
let's even go more simple. 2 steps forward. What's your distance? 4 steps. What's your displacement? Nothing. Okay. So let's go true. And as an explain, how about 2 meters forward, 2 meters backward? That's 4 meters of distance, 0 meters of displacement. Danica, you okay with that? Okay. Manveer, we convinced you? Yep, it's okay. Someone's got to vote for the Rhino Party too. You know, it's always happened. Yep, it's all good. Ooh, example 11. An object can have a positive distance while having a negative displacement. Once again, we're going to vote. Once again, how high you hold your hand up is how sure you are of the answer. So an object can have a positive distance while having a negative displacement. Ooh. Who says, Mr. Dewick, this is obviously true? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Who says, no, what are you talking about? What voodoo is this? I got 1. I think some, nope, that was just okay. I think some people voted a bit late. Convince me. Convince me. Read.
So if you take 1 step forward and take 3 steps backward, you went 2 meters. If each step is a meter, you went 2 meters backward, and it's still traveling forward.
D is 4. D, displacement, vector sign, -2. Yeah? Yeah.
How do we get 18 people to cheer for the second?
Because some people were slow in voting when I was going across. I saw some hands go up out of the corner of my eye, and I didn't get a chance to go count them. Good point. What, you think there's election fraud? No, that's in the U.S. Oh, never mind. Turn the page. An object can have 0 distance while having a positive displacement. True or false? Once again, we're going to vote. Once again, how high you hold your hand up is how sure you are of the answer. So an object can have a distance of 0 and also have a positive displacement. Huh. Who says, totally can't? True, Mr. Dick. This is true. True. You got 2. You've swung one voter over. Who says false? Convince me. What?
So having positive displacement means that you ended up somewhere else, but you had a problem.
Distance is the number of steps you take or the number of meters you move. If you haven't moved any meters, will you have a change in position at all? Ah, I agree. So, if distance is 0, no change in position is possible. Yes, sound right? One of my favorite comics is Foxtrot. The author, Bill Ammond, actually has his physics degree. And while he was doing his physics degree, he also did a lot of doodling, and somebody said, hey, these are funny, you should make comics out of them. So he writes about a family, and the family has a young boy I identify with. It's Jason. He's the young nerd. This is Jason right here with his older brother, Peter. They're playing football, and Jason says this, okay, here's the play. Go 40 yards downfield, then turn left and go 20 yards, then turn right and go 25 yards, then turn left, then turn right again and go 30 yards, then turn right and go 30 yards, then turn left and go 10 yards, then turn left and go 15 yards, then turn left and go 20 yards, then turn left and go 50 yards, and I'll hit you with the ball. Peter thinks for a while, and he says, won't I be right back where I started? Jason says, I can't throw very far. So, first question. What distance will Peter run in order to complete this play? Well, 20 plus 25 plus 30 plus 30 plus 10 plus 15 plus 20 plus 50. I think that's it. I can do this in my head. 20, 25 is 45, 75, 105, 115, 130, 150. No, I'm off. 20, 25, 75. Or did I write this down wrong? Did I make a typo, Mr. Dewick? 50. I think I missed a 40. I missed the 40 at the start, Mr. Dewick. The nice thing with digital ink is I can just do this and nobody knows the difference. Let's try that again. 40 plus 20 is 60, 85. 85 plus 115, 145, 155, 165, 170, 160. Is it 240? And the abbrev for yards is Y. That's why the abbrev for years is A. What's the answer to B? What's Peter's displacement if he ends up right back where he starts from? 0. We have actually gone out on the field and run this play just to see if it works. And the physics is correct. You do end up right back where you started from. No, we're not going to do that today.
Why do you rank 240 yards just to make that?
Oh, it's good physics, though. Just saying. What's your homework? You're going to work on this after the test, the quest tomorrow, because we're actually going to move into a little mini lab, kind of a fun one where you get to yell at each other. So number 1. Number 2. By the way, technically, what's the displacement in any car race ever if they're on a track? Yeah, they technically go nowhere under physics. They travel a distance, but their displacement is 0 because they always end up back where they started from. 2 is good. So in number 2, you can assume each one of these squares is 1 kilometer by 1 kilometer. Number 3, when I photocopied it, the initial and the final, the I and the F were hard to see the difference. So I hand wrote a little I and a little F right there so you know which one is initial, which one is final. Same with number 4. Try 5. Try 6. 7. 8. 9. Are you going to assign every question, Mr. Dewitt? Probably. 10. And I did attach the answers.